Lesson 6-2, substitution. So we've already gone through solving a system of equations by graphing. Another way of solving it would be using substitution. So exact solutions result from algebraic methods that are used to solve systems of equations. One of these algebraic methods is called substitution. So substitution means exactly what it is. You're substituting a value in for the variable to solve. And you're going to use one to find the other variable. So how do we do this? When necessary, solve at least one equation for one variable. This means make it into like y equals mx plus b format, or x equals my plus b. Step 2 says substitute the resulting expression from step 1 into the other equation, replace the variable, then solve the equation. In step 3, substitute the value from step 2 into either equation and solve for the other variable. Write the solution as an ordered pair. So an example, 3x minus y equals negative 7 and y equals 4x plus 11. Now here I already have one of the equations solved for a variable. Y is by itself here. So what does y equal? Y equals 4x plus 11. And I'm going to use this, since that's what y is, I'm going to put that in for this y, so then I can solve for x. So if I do that, I'll put 3x minus, and then here's the important part. Put it in parentheses, 4x plus 11, and then this has to equal negative 7. Now, since I'm subtracting all that, I'm really distributing a negative 1. So this is really 3x minus 4x minus 11 equals negative 7. And now I can combine like terms, and I get negative 1x minus 11 equals negative 7. To get x by itself, negative 1x by itself, I add 11, and I'll have negative x equaling a positive 4. Divide by negative 1, x would equal a negative 4. And if x is negative 4, I can now put this in for this x to find my y. So y would equal 4 times negative 4 plus 11. 4 times negative 4 is negative 16, plus 11 will give us y, and y would equal a negative 5. So my answer as an ordered pair would be negative 4, negative 5. Another example. Use substitution here. Again, my y is by itself, and I can substitute that in for this y. When I do that, I end up with 8x minus 4 times parentheses 4x plus 5 equaling negative 4. To get rid of my parentheses, I'm going to distribute a negative 4, and I have 8x minus 16x minus 20 equals negative 4. Combine like terms, so this will give us negative 8x. I'm going to add 20 to both sides, and that's going to equal a positive 16. To get x by itself, I divide by negative 8, and I'm left with x equaling a negative 2. Now I can use that to substitute this in for this x here. I could do it in the other equation, but since I'm trying to find y, I already have y by itself. That would be the easiest equation. So 4 times negative 2 plus 5. So y equals negative 8 plus 5. Y would equal a negative 3. So my answer as an ordered pair would be negative 2 and negative 3. Now you don't have to put it as an ordered pair. You could just still write x equals negative 2 and y equals negative 3. That I'll leave up to you. Moving on. Referring to the system of equations below, we need to write which expression could be substituted for y in the first equation to find the value of x. So since this is what y is, I can substitute that in for y in the other one. 2x plus 2 would be letter C. Now part B, what is the solution to the system? So now we would have to solve that. So I would have 3x minus 2 times 2x plus 2 equals negative 17. Distributes, so we have 3x minus 4x minus 4 equals negative 17. Combine like terms. I now have negative 1x equaling a negative 13. Divide by negative 1. X would equal 13. So if x is 13, I know I can already eliminate a and b. Now if I put 13 here, 2 times 13 is 26, plus 2 would give us 28. The only answer that would be valid would be letter D, 13 and positive 28. Example 2 here. They're both equations are in standard form. I need one of them to be where the variable is by itself. The easiest one is this x because I don't have a coefficient besides 1 in front. So I'm going to subtract 4x on both sides, or 4y. And now I have x equaling negative 4y plus 18. This is what x equals, and I'm going to substitute that in for the x in the other equation. So now I have 5 times negative 4y plus 18 minus 3y equaling a negative 25. Now it's important that you make sure you only have one variable left when you're doing the substitution, which I do. Now I distribute the 5, so this will give us negative 20y plus 5 times 10 is 50, 5 times 8 is 40, so 50 plus 40 is 90, minus 3y equals a negative 25. I subtract 90, and then combine like terms, I'm left with negative 23y equaling a negative 115. Divide everything by negative 23. Now my calculator, I have negative 115 divided by negative 23. I get an answer of y equaling 5. And if y is 5, I can substitute that in for y here to solve for x. This gives us negative 20 plus 18 to get our x. X would equal a negative 2. So as an ordered pair, we could have negative 2, comma 5. More examples. Here I'm going to subtract 3y. Now I have x equaling 2 minus 3y. And I'm going to substitute that in for x in the other equation. So I have 4 times 2 minus 3y minus 12y equals 8. Distribute, I get 8 minus 12y minus 12y equals 8. And subtract 8, combine like terms, I get negative 24y equaling 0. Divide by negative 24, my y would equal 0. And if y is 0, x minus 2 minus 3 times 0 would give us x equaling 2. So my ordered pair would be 2, comma 0. Another example, subtract 2y on both sides. Now have x equaling negative 13 minus 2y. I'm going to now substitute this in for x in the other equation. And I have 5 times negative 13 minus 2y plus 3y equals 5. It distributes, that's negative 65 minus 10y plus 3y equals 5. Combine like terms, and add 65 on both sides first, and I get negative 7y equals 70. Divide by negative 7, y would equal negative 10. Plug that in, negative 10 minus 2 times negative 10 will give us x equaling negative 10 plus 20. X would equal 10. So our ordered pair would be 10, negative 10. Example 3, use substitution where there are no or many solutions. So again, I'm going to substitute this in for y. And now I'm left with 4x plus 2 times negative 2x minus 4 equaling negative 8. I'm going to distribute. So we got 4x minus 8 equaling negative 8. When I combine like terms, I'm left with negative 8 equaling negative 8. Because both sides are equal, I know that this is many solutions. Which just means I can put any number in and it will work. Now, if I would have put the 8 to the other side, I would have ended up with 0 equaling 0, which as long as both sides are equal to each other, they're identical, it's always many solutions. Next, substitute this in for y, so 3x plus 9, so I have 6x minus 2 times 3x plus 9 equals 2. Distribute to the negative 2, and I get 6x minus 6x minus 18 equals 2. On the left-hand side, I'm left with negative 18 equals 2. Negative 18 does not equal 2, therefore we have no solution. No number in there would make sense or make them equal. This is also no solution because the lines are parallel. They have the same slope, which means they never cross. Next, select the correct statement about system of equations here. Here, if I were to add x to both sides, I would now have 2y equaling 2 plus, or x plus 2, and then divide by 2. I would now have y equals 1/2 x plus 1. If the top one is 1/2 x plus 1 and the bottom one is y equals 1/2 x plus 1, the system has no solutions. They would be many solutions because they are the same exact equation. Now, if it was just, if the y-intercepts were different, then it would be no solution. Because they're identical, the equations are identical, it would be D, many solutions. Example 4. Now using a word problem, found ordinance defines an adult tree as having a diameter greater than 10 inches and a sapling having a diameter less than 10 inches. The ordinance requires that on a new building project, 2 new trees are planted for each adult tree felled, and 6 new trees are planted for each sapling felled. Last year there were 167 trees felled, and the community planted 742 replacement trees. How many of each type of tree were found? You need to come up with 2 equations, one for felled trees and the other one for planted. So for the felled trees, I'm going to use A for adult and T for I'll use T for the saplings. Okay, so the felled trees, so we know A plus T has to equal 167 because 167 trees fell. The other one, planted, they plant 2 for each adult tree that fell, plus 6 for each sapling that fell, and that was a total of 742 trees. We need to solve for this one. So to do this one, I'm just going to solve for T first. So I'm going to subtract A and then substitute that in for T here. So I have 2A plus 6 times 167 minus A equaling 742. So I distribute, I have 2A plus 167 times 6 gives us 1002 minus 6A equals 742. If I subtract 1002 on both sides, I have negative 4A equaling 742 minus 1002 gives us a negative 260. If I divide by negative 4, I end up with adult trees, 65 trees. So if 65 of the 167 were adults, that means the saplings would be 102 trees. Next. Travis's pickle house sells pickle seeds for $1 each and jars of pickles for $7 each. Last week he sold a combined total of 208 spears and jars for $592. How many spears and how many jars were sold? So I need two equations, one for the number and then the other one for the money. So the number, so I'm going to use P for pickle spears and J for jars. So I know that spears plus the jars has to equal a total of 322. And then it's $1 for each pickle spear, so 1P plus 7J for each jar gives us a total of $592. So if I solve for J, I'm going to subtract P on both sides, and I substitute that in for J. So I have 1P plus 7 times 322 minus P equals 592. And I distribute. So I have 1P plus 322 times 7 is 2254 minus 7P equals 592. So I have a negative 6P. If I subtract 2254, 592 minus 2254 gives us negative 1662. To get P by itself, I divide by negative 6. And I'm left with pickle spears, 277. And then that means the number of jars sold. If I put 277 here, 322 minus 277 will give us 45 jars. And our last question. Money has two equal size large pitchers and two equal size small pitchers. All of the pitchers together hold 40 cups of water. The capacity of one large pitcher minus the capacity of one small pitcher is 12 cups. How many cups can each type of pitcher hold? So I'm going to use large and small. So I know that's the large plus the small has to equal 40 cups. And it says the capacity of one large, so one large is minus, so the large minus the small is 12 cups. So those are my two equations here. And there are a couple ways of solving this one, but I'm going to continue that with substitution. So here, if I were to add s to both sides, I would now have L equals 12 plus s. And if that's what L is, I can substitute that in for this L. And so I would have 12 plus S equals 40. Now I subtract 12, and that gives me two S's equaling 28. Divide that by 2. Small pitchers, we would have 14. Then if I would substitute that in for S, I could solve for L. But there was one thing I missed in the original problem. It says 2 equal size and 2 equal size small pitchers. This isn't L plus S equals 40. This is actually 2L and 2S. So now I have to change my problem just a slightly different. So this is 2S times 2. Now if I do this one correctly, this would be 24 plus 2S equals 40. Then subtract the 24. I now have 4S equaling 16. And then divide that by 4. For small pitchers, I would have 4 cups. Then I can substitute that 4 in for S. If I substitute the 4 here, or not there, let's do the 4 down here. So if I substitute the 4 here, 12 plus 4 would give us 16. So you would have 16 cups for the larger ones. So make sure you read carefully. Don't make the mistake like I made. I forgot to read that there was 2 pitchers for each. So that is our lesson today on substitution.